equations can be a little tricky, but it's actually quite straightforward. Suppose you have a homogeneous equation and you're trying to solve it. If you make the substitution y is equal to vx, where both v and x are differentiable functions of x, and then of course dy is equal to v dx plus x dv. So if you make these substitutions into your differential equation, you'll be able to separate it. So here's a review of the steps. First, verify it's homogeneous. Do the change of variables. Use a chain rule for dy. Replace y and dy in your original equation. Then solve your differential equation in x and v. Your final step is to substitute back in v is y divided by x. So let's look at this differential equation. It is indeed homogeneous of order 2. So I'm going to plug in y is equal to vx and dy is v dx plus x dv. So when I plug in, this becomes x squared minus vx squared times dx plus 3x, now for y I put in vx, and dy is v dx plus x dv. Now the easiest thing here is to just multiply this out. I have x squared dx minus v squared x squared dx plus 3x squared v squared dx plus 3x, and I believe I have cubed, v dv, and this equals 0. Now what I want to do is collect all of the dx terms on one side and all of the dv terms on the other. So I'm going to leave the 3x cubed v dv on the left side, and I'm going to subtract off the rest of these. So this is v squared x squared, and I'm going to factor at the same time, minus x squared minus 3x squared v squared dx. Now I'm going to see if there's any way I can pull anything out of here, and the answer is, oh, look at that, yes. Okay, this is x cubed v dv. I'm going to pull an x squared out of each term. So I'm left with v squared minus 1 minus 3 v squared dx. Okay, so I need to separate this out a little bit. Let's see. First of all, I can get rid of these two, and I'm left with 1 here. So 3x v dv is equal to v squared minus 3v squared is minus 2v squared minus 1 dx. Now I can separate variables. So I've got v dv divided by, now I'm going to factor this negative sign out because it's bugging me, 2v squared plus 1 in my denominator, so all my v's are on the left, equals, let's see, I've got dx over 3x. I usually bring any constants over to the right. So now I can integrate. And let's see, if u is 2v squared plus 1, du is 4v dv. So I need a 1/4. And I'm going to factor this negative sign out. So this becomes minus 1/4, the natural log of 2v squared plus 1 is equal to 1/3 the natural log of x. Oh, let me simplify this out a little bit. I have let's see, let me multiply through by my constant. Oh, I forgot my plus c, didn't I? So before I go on, let me put my plus c. So I have the natural log of 2v squared plus 1 is equal to minus 4/3 natural log of x, and it's still plus c. The constant does not change. So I want to get rid of, let's see, let me get rid of my x. Let me make this the exponent of e. So I'll make this the exponent of e. So I have 2v squared plus 1 is equal to x to the negative 4/3 times a constant. And I don't know what that constant is, but that's all right. So this is equal to cx to the minus 4/3. Now I don't like that minus 4/3, so let me raise everything to the minus 3/4. So this becomes 2v squared plus 1 to the minus 3/4 is equal to, now this is still some constant, times x. Um, well, at this point in time, we're just sort of going around in circles. We need to substitute back, and we know that if y is vx, then v is y divided by x. So substituting this in, we have 2y over x squared plus 1 to the negative 3/4 is cx. And the really only way to solve this any further is to have some sort of initial condition or know that you need it in a particular format.